Welcome to the Fedora Podcast. This is the final episode of Season 2, Episode 10. This is the podcast to teach you about how the Fedora community works. We bring you news, interviews, and more. I'm Grayson, and with me today I have David Duncan. He's here to tell us about Fedora Cloud. This is the Fedora Podcast, a proud member of the Destination Linux Network. Hi, David.
Hi, Grayson. How are you?
Good. Thanks for coming and talking to me today.
I'm really grateful that you asked. This is such a fun, podcast, and you do so much with so many people. It's really fantastic. So thank you so much.
Thank you.
Yeah.
The first thing I want to know is, who are you and how are you involved in Fedora?
Let's see. How do I identify myself? I think I'm currently a solutions architect working at Amazon Web Services, and I live in Austin, Texas. Although I'm here in a little cabin my family cabin that I built with my dad many years ago. So
That's pretty cool.
Yeah, and I have been involved with Fedora since the move to Fedora happened. In fact, so I was involved in building systems solutions for customers. Right, I was doing solutions integration in Austin, and I got involved with Fedora because I was using Red Hat 9, and there was this big switch to enterprise Linux, and I was already working with a lot of friends, on different projects. The Linux in Schools project at that point was called the Terminal Server project back in those days, but still same project. And working on small nonprofit organization configurations, and Fedora was sort of a natural progression, because with the move to RHEL 2.1, some of those nonprofits didn't have big budgets. They didn't see where they were gonna use a commercial product, and so I thought, well, let me just get involved here and see what's going on at the community level. And not being a great developer, I jumped right into advocating. Right, so the first place that I became fully involved in the project was jumping into the Fedora Ambassadors Program. Right, something that has evolved into much stronger experience today. But at that point, we were just showing up and telling people about Fedora and using it as much as we could in our daily lives, and then sharing the experience with each other and with others, and shipping that giant swag, the booth and the swag kits all over. And my first big contribution in the ambassador program was taking on the responsibility of the Fedora tattoos. So
I love those.
the temporary tattoos. So I learned a big lesson there about what it's like to try and make a commercial temporary tattoo, and how to ship that all across the world and then get reimbursed. Right. So
That's so cool.
yeah, but I used Fedora pretty much everywhere that somebody said, wouldn't it be great if that was the first start, and it was definitely directly connected to Red Hat for a lot of commercial deployments, but then Fedora as a community extension. To me, the best part about it was getting involved with the people who were in the project, and and learning together.
Fast forward to today, what do you do around the Fedora project?
Well, now I work primarily on the cloud configuration. I've been supporting the work or efforts um, around sort of cloud adoption and building images that were really useful and effective across multiple architectures, and as those architectures have become available on different public clouds, um, and then just trying to make sure that people are aware of what can be done, how to use tools like EC2 Image Builder and which is the OS Build project in our world, in the community world, and just generally trying to make that cloud experience better, working on cloud init um, and the integration there, and yeah, just keeping up, putting my 2 cents worth in.
That's a lot to get into.
Yeah.
To start off, what is the Fedora Cloud Edition?
So I think the idea is that the cloud edition is sort of set to be um, an image you can use anywhere in a virtualized environment, right? So it's the foundation um, for build or a building block for simple systems that can be, you know, self-contained, uh, golden images. Like you can create sort of it's a base image, a golden image that you can use to create further configuration, save that configuration in a new image, and then use that to have readily available configurations for projects. And then on to that, so moving on, you start to see that in the context of the hyperscaler, or the concept of the hyperscaler. You know, fast forward or early on, we were looking at just doing this for OpenStack, right? And then but then the public cloud came along. Like lots of people started to have big virtual servers, and there was a need, like a clear need for a configuration that could be used in those architectures, and they were fail only, right? Um, like uh, like when Amazon EC2 came on the scene, that was one of the things that you could tell about it immediately, right? First off, they were working directly with Amazon at that time, was working directly with Red Hat. And then there was a Red Hat image, but the Fedora image came about, was sort of burgeoning at that point. Um, and and we were looking at ways to create an image that was consistent for a large number of those hyperscalers, right? DigitalOcean, um, then Azure, Google, obviously, right? Now there's hundreds and literally hundreds, and we try to keep a strong generic image that can be used across all of those.
So Fedora Cloud started out working with just OpenStack, then it grew to work with most of the different VPS providers. In the beginning, where did it come from, and why was it created?
Well, I think it came from just the basic concepts of virtualization were, the first ones we had. I mean, so, with Zen, there had to be an image that people could use. It wasn't just it didn't just simply appear, right? It had to be created. And so there were a couple of different ways that happened. We were all used to building our own. But then it became kind of clear that, as the ISO wasn't the only way that we were going to get boot up. There were a lot of environments that didn't have access to the ISOs, or it was inconvenient to build your own. Like it was a more complicated experience than people wanted to take on. So providing a ready-made image was the easiest way um, to move that forward. I don't remember exactly when it became the cloud image, but sometime in the early 2000s, it was kind of clear that there was going to be a need to have just base images that everyone could consume. And eventually we called it the cloud, right?
So I don't know if this will come out long enough to be its own question, but I wonder, what does the Fedora Cloud SIG do? Do you guys just create the cloud edition, or is there anything else?
Well, I mean, so yes, we make Fedora Cloud, but then there are other things that we're doing, I think, that are kind of um, that are interesting in the sense that we're working with the specific providers to hear what it is that they need get done, right? What is going to be important for how um, their infrastructure functions, right, and what their expectations are, and then making changes or ensuring that we're advocating internally for providing some support for whatever it is that they need. Right? So I think we have a little bit more. It's a little bit farther reaching in terms that in the sense that we're not only representing um, the the interests, but we're also advocating strongly for the requirements that make Fedora run better on those infrastructures.
Mm-hmm.
So, and that doesn't mean that uh, there aren't times where we make a decision and it turns out that it needs some help to work better on some other architecture. Right? We just went through that with the way that the some new features for Fedora 35, and we'll get into that later. But we found some problems. We work them out. That's kind of what we do. So we find the things that we think are best for next generation. We do those, then we determine, um, you know, try to fail fast and uh, um, and learn what the right answer is going to be together. Um, Cloud is different in that sense the um, because the pace of new hardware and the availability of new hardware is a lot different than it is for, say, server, where you have to be very careful about how stable you are from beginning to end of those generations, hardware generations.
Do you have a specific role in the Fedora Cloud SIG, or do you just kind of do a lot in there?
So um, it's been up until recently, it's been very generic, and now I would say that I work to co-lead with Dusty Mabe, who has been strongly responsible for the cloud group for a long time, but he's stepped back some of his responsibility, and I've tried to pick that up where I can, and in an official capacity.
Just a minute ago, you touched on some of the differences between Fedora Cloud Edition and Fedora Server. Could you expand on the differences between those?
Yeah, I think so. Clearly, the one thing that I think is very specifically different about server and cloud is that server has a responsibility to create a stable infrastructure configuration across many different architectures, many different infrastructures for customers, and then or for users, and then to provide all of like the networking services, the configuration requirements to be able to provide supporting structure for all of the different um, network services that are required, or that are requisite for building a strong network. Um, and we don't have that in cloud. In cloud, we those responsibilities are sort of separated. So our goal is to ensure that whatever a customer has, whatever they or whatever a user wants to do, that they can get a purpose-built configuration uh, uh, done that doesn't have any of doesn't have a lot of the same, like all of the additional packages, right? There's not a base package um, group that we want to have that we say is canonically identifying that this is this is a cloud edition. The cloud edition is really identified by what we remove, like firewall D, for example. I think that's a really interesting one that that from the cloud perspective, we don't expect there to be a firewall on the system. Uh, but no one would leave a server, right, a server edition with no firewall.
Just a minute ago, you touched on how Fedora Cloud can be run on all kinds of different VPS providers. Other than the generic VPS providers where you just click, I want Fedora on my VPS, where else can you run the Cloud Edition?
I mean, the best place is on your Fedora workstation, right? So with some of the new changes in KVM support and support, specifically support for Cloud Init, it's a great little tool for building purpose built for building images that you can use over and over again, and you can create configurations to experiment with, to wake up, to destroy, in different ways that serve your purpose, right? Um, so I think right right on your desktop, right on your laptop is one of the better, is one of the best places to run it. And then beyond that, um, there are many different environments where virtual machines can become the best kind of server. I have a NUC, just an Intel NUC, that's running multiple virtual machines, and one of the virtual machines' responsibility is the image pipeline for building out for copying the official images into the AWS marketplace, and it just spins up, does its job, and then it dies, right? So it shuts down, and when it shuts down, we're done. And the majority of that is done through Cloud Init, right? So because I mostly because I can, and because I work with cloud all the time, I'm really comfortable building a cloud config, and then supplementing that with Ansible. But that's it's another story. I think just generally, there are lots of places where, for very purpose-driven jobs, it's a great experience, and for testing. Yeah, I know everybody loves the container today. I appreciate the container's role in exactly that, but sometimes it helps to know that you're going to get that you're getting the entire environment, and you may want to have multiple containers involved in whatever it is that you're doing on top of that.
That's pretty cool. So I'm getting remo- tell me if this is wrong, but I'm getting the idea that this is kind of like um a fuller container where it's quick to come up, quick to go down, stateless, does one thing, but it's got a bit more underneath it than a container does.
Yeah, it comes. These are some of the early days of microservices, right? Were some of the places where this began. The concepts of the minimal server started to gain traction in the Linux world, and we had there were all sorts of things going on at the same time. LXC was coming up. People were very excited about how they could use that. That obviously has a limited reach. Lots of people used it, but it still has kinks, and the same thing goes with just a minimal server. But But yeah, you can get in there. You can find workloads that are simple and strategic, and get them done. And yeah, it's great in the context of testing and things like Jenkins, or and especially if you're doing hardware development. I have a great friend, Gal Pressman, who does a lot of hardware testing and RDMA core testing in the the HPC world, and he does this with cluster technologies to make sure that he's got the right hardware and RDMA communication stacks together, ready to go. And some of that happens on his desktop, and some of it happens, just out in the cloud.
What's RDMA?
Remote direct memory access. So it's a technique for communicating between two servers or multiple servers, where they're sharing fast path access to data values in memory.
Interesting.
Yeah, it's used in high performance computing quite a bit.
So, say you've intrigued me and I want to now run Fedora Cloud somewhere on a machine. How can I get it?
Oh, well, that's great. So the the first place you would want to go is to the Fedora Project's cloud alt um, page, and you'd want to pull that down. I'm sure we can put a link in the notes. But
It will be there.
yeah, but the cloud images are all set together on a couple of pages. There's the just the basic download of the raw image, and the raw image can be imported into many different environments, or like I said, just use it on your workstation. Um, and then there are links to the the cloud images that have already been uploaded to different public providers, so that if you're um, if you're just looking to get started, you can just launch an instance on Google, or launch an instance on Azure, or you can launch an instance. Well, sorry, not yet on Azure, but you can launch one on Amazon. We're working on the Azure Marketplace right now. But um, but you can launch, pretty much in whatever environment you want to, from the link on that site. And then if it's not available, if the one you're looking for is not available, you can use the image and import that image into your whatever provider it is that you want to get started with.
If you're running it on your machine, would you just put it in a generic libvirt QEMU type virtual machine?
Yeah, yeah, that's an easy way to do it. You can set up a bridge network and just run it on a standard libvirt system. One of my favorite things to do is the libvirt tools include this great um, this handy tool called virt sysprep. So if you're creating an image and you want to you want to do updates, and you want to install some software, and you want to make some changes, you can do all those changes, reconfigure it, and then you can use the virt sysprep. You can use the guestfish tools, something like the guestfish tools, to make the modifications on the system. Then you can use the virt sysprep to remove all the traces, like the machine IDs, the any of the artifacts that would have been there from boot, or from like creating a user. All that is deleted and then left in the hands of the cloud init to reconstruct at first boot. So there's some cool tools out there that you can use to make this virtualization experience customized, and to just enjoy it. If anybody wants to talk about that, I'll talk about it all day. So
That's cool.
yeah.
Technically, how are the Fedora Cloud images built?
So they're built with Image Factory on Koji, and and they're built based on the kickstart. So we use a kickstart configuration. That kickstart configuration is then used um, to create an image of a specific type, and then we have a naming structure, and you wouldn't believe how important the naming structure is, because we build these images all the time, right? Every couple of weeks or so. When they're deployed to the environments, these public environments with the public clouds, um, those images start to add up. You start to see a lot of them, right? Um, and so it's good to know that you've got latest, right? A lot of times it's easy to find the latest image, but then if you can't sort them with the naming conviction with a naming convention, it becomes very difficult. So we try to be very specific about the naming, very consistent, and and then those images are built, they're tested, they go through the same sort of CI process that we have for the workstation server, um, and then we do cloud days, Fedora Cloud days, for testing, or Fedora test days for cloud, which we have one coming up in October 11th and 12th. Um, and then those images get pushed to the various providers so that they are available. Um, it's and to the website so that you can download them for yourself.
Is Fedora Cloud built on anything? Or is it from the same abstraction of not being built on top of anything that server, desktop are built on?
Totally the same. So yeah, I mean, obviously this is not a spin, right? It's consistent with the standard configuration. So there's no deviation. If you let's say you decided you wanted to install some package. Well, there's nothing else installed. I guess that's the right way to say it. Is there's nothing installed there that's going to be different or deviate from the standard configuration or the expected configuration. So we try to keep it consistent. We don't want to do anything that's going to be considered to be outside of the expected changes, and we follow the same change proposal requirements that everybody does, and we consider those to be um, expected to be a part of the system, right? So I think the most radical thing, the most radical differences are related to the kernel parameters and things that are associated with curiously different experiences on cloud. So to give you, let me give you a kind of an example. In the world of AWS regions, there are availability zones, and in the configurations there, most of your block storage devices are networked, right? So um, if you have a server that it goes offline for some reason, let's say the region or the availability zone in a region becomes unavailable, and that instance then is no longer capable of accessing. You're no longer capable of accessing that instance, right? You've created an instance from the cloud image. If the networking connection fails on an NVMe device, it could take a long time for you to get to complete your last read or to complete your last flush. And an NVMe device usually has a timeout, like a read or a write timeout of about 4 milliseconds. But we extend that in our configuration for the IO timeout to the maximum size of the integer for whatever given architecture it is, right? So, and the reason we do that is because it could take a day for it to get back, but it doesn't matter because it's a network device functioning as a pseudo PCI, right? So it looks like an NVMe device, but it's really being accessed across a network connection using the same instructions that you would expect you would use with a very low latency device like the NVMe. Well, it can take forever, doesn't matter. So we extend that timeout to something that would be absolutely crazy to do on premises. So if you were using server, you wouldn't want to do that. But using cloud, totally would want to let it come back whenever it does, whenever it's ready.
That's crazy that there's just like differences like that you wouldn't even think of, but make Fedora Server just inefficient to do in that use case.
Well, I mean, I could make the modifications that would make server, that would make server function that way, but no one would want it on premises, right? You would never want that on your home server or on your laptop, for goodness sake. And if your file system wasn't accessible for 4 milliseconds, you'd want somebody to tell you. That'd be a long, that's a long time to not flush to disk if you're, if the information is important. So yeah, it's different. It's, there's a different experience there, different way of handling error handling and whatnot because of the shift in paradigm.
The Fedora 35 release is coming up soon. What is new for Fedora Cloud in Fedora 35?
So there's two big ones, I think, that are most notable. One is we've moved to a hybrid boot configuration. So it used to be that we just used the classic boot configuration on the Intel systems, and then we used the UEFI or Wi-Fi, however you want to say it, the boot model um, on the AMD instances, or I'm sorry, the ARM instances. So, um, but there has been sort of a dramatic change in the acceptance of UEFI on public clouds, and so in preparation for the days when Classic Boot is no longer supported, we have integrated a hybrid configuration that makes it possible for us to boot the images regardless of whether or not the instance configuration is set for UEFI or Classic Boot. The second one is we've moved from a standard ext4 file system to Btrfs.
Yay,
Sort of
Btrfs.
similar. Yeah, so we're moving, similar to the way that the workstation has moved um, to Btrfs. We are also moving to Btrfs. There's some interesting things about Btrfs that are very cloud friendly, and I'm very excited about that. So one of the things that we face complications around in the cloud world that I think this is a great opportunity for us to explore how we can change this for everyone, or how everyone can start to look at why Btrfs is a better fit is in classic uh, STIG hardening or the hardening, the CIS benchmark requirements for secure systems requires you to have these complicated partition structures that are not a part. This is another one of those cloud sort of cloud variations. We don't create partitions on the cloud instances, and the reason we don't create partitions is because um, there's really no need. I mean, if the system fails, right, like on a server, you've got to really you've got to lock down whether or not the log files are going to take over the system, right? You never want a system to run out of disk space because logs, right? You want to make sure that whatever your applications are, they're separated off into var, and their space um, can't stop logging, and vice versa. But on a cloud instance, you're not worried about that. If the instance for some reason becomes unusable, you will destroy it and make a new one, right? So typical load balancing configurations tend to have systems that are logging. Um, they either log remotely or they log locally or they both. And and if you have a workload that becomes unresponsive, then typically your instance requirements uh, are to just let it die and replace it, right? So whatever its function is, it should be functionally replaceable. Um, we don't create complex partitions, but that's still a requirement for this, these secure systems. So secure systems want to have uh, these variations um, in the partitions. We can't satisfy that after the fact. It has to be done prior. So if we were going to do that, we would have to create additional images that had variations in the way that they were configured, and pretty soon you'd be inundated with these like purpose-built cloud configurations. And our goal with using ButterFS was to leverage the subvolume as a way to repartition the system, uh, regardless of what that base partition looked like. So we create one single ButterFS strategy, but it's something that we can manage a significant number of variations on, in the way that file system access works. And so we're hoping that that will improve, and we'll see better, we'll see more adoption, and people will see that. And then there's some other things like volume snapshots. You can create these really sort of fast and easy acting volume snapshots that you can then send to different volumes and then use those across multiple systems. So if you actually are making modifications and you want to start up hundreds of different systems that have, you know, mild variations in the way that they are configured to get like changes in performance or whatever, then this gives you a great test bed or ability to do lots of different variations in blue green deployments, which we see, you see in a lot of cloud configurations. If you looked at the number of machine images that are created by Netflix, for example, in a given day, you'd see that, there's thousands, and they're testing those all the time.
ButterFS has a lot of features that are crazy cool and also crazy
Mm-hmm.
complicated, but I'm sure are going to be super useful in Fedora Cloud.
I think so. I think that I'm looking forward to it. I want people to give it time. I know that the server team is not ready to see ButterFS, and I think that that's a reasonable stance for the kinds of complex volume configurations that they want to do, um, and for many generations of older configurations that maybe aren't. Um, well, they definitely aren't really apropos of cloud configuration, right? So we want to make sure. I know that they have their reasons for holding off, but we thought that this was definitely the best time for us to move forward. So for Fedora 35, ButterFS, all the way, super excited that we're making this move, and it was about time we moved off of ext4. That's all I have to
Definitely.
say.
Self plug, if you go back to episodes 3 and 4 of the Fedora podcast in this season, we had Chris Murphy on to talk about ButterFS, and we had a lot of interesting discussions.
This is really amazing. He's been a great part of our move to ButterFS in the cloud sig, and so it's been really fun to work with him, and I very much enjoy his style. So yeah, he's very knowledgeable. I think he put in like 8 bugs the first day we started talking about it. Just boom, boom,
Wow.
boom. Right. Here's what we're going to face with containers. Here's what we're going to face with, and just really had a great handle on where we were going and what was going to be necessary. The container space is somewhere we're still working, but um, we're hopeful that we'll have the right kind of drivers in place for making making the container consistent.
Chris is awesome.
Yeah.
My last question for you is, how can people get involved in Fedora Cloud if they want to help out, file bugs, any of that type of thing?
Well, so, I mean, big plug for Fedora Cloud test days and all of the work that Sumantro has done. What an amazing guy. Just want to plug his efforts around test and how easy he makes it to be a part of the Fedora test days. So definitely need you out there testing. Definitely need you testing on the public cloud of your choice, the your local configurations. We want to see it all, um, and private clouds too. I mean, we really want to see the results that customers have or users have with their private cloud. So um, beyond that, the use cases, right? Like, what solutions are you are you looking at for? And I don't even care if Fedora Cloud is not the first target. I just want to know, like, what would you like to see in terms of cloud solutions? We constantly forget that. I think that because we're so excited about getting things done and having this Fedora next, we forget about how many solutions people really want to hear about or they want to get things done, right? And so you want to hear. I want to hear back what people want to see. I would love to see more people interested in specific workloads. Like, I'm really excited about making Neuro Fedora spin work in cloud, right? I mean, I know that there are a lot of people who are using the same kind of tools, but it would be really great if we could bring those spins in. We started to look at really a lot more solutions, and we built some narratives around that. So, I mean, any way they want to get involved, I'm super happy, right? They want to make artwork. They want to do narratives. They want to they want to write code. They want to improve the kickstarts. They see variations that they want to bring, or they see like changes that they want to make things better for specific environments. I'm all for helping them do that. But then getting involved, just test days and come to the Fedora Cloud SIG meetings if you can, um, and we'll find something for you to do. If you don't, if you come in with no bigger idea than I want to do something on cloud, we're going to get you started, and we're going to be your biggest cheerleaders. Right?
That's awesome.
Yeah.
Do you have anything else you want to add about Fedora Cloud? If you don't, that's okay.
I think that the big thing here is, yeah, we'd love to see more solutions. I'd love to talk to people about what they're doing with cloud, and so bring all of that to our meetings and tell us all about it. We're looking forward to making it better.
Thank you, David, for coming on the show and talking about this. This has been a really fun interview, and I can't wait to publish it. And yeah, thank you.
Yeah, I'm glad you did it, and I'm super excited about being a part of the podcast.
It's bittersweet to know that this is the last time this season that I'm going to get to read this outro and then play this music. After this episode ends, the Fedora Podcast is on an indefinite hiatus. At the moment, nobody, including me, has enough time to run this show. It's sad, but necessary, that we don't know when we'll be back. However, I am hopeful that we'll be able to release new episodes, maybe around mid-2022, but no promises. I'm also hopeful that we can release some special episodes in between then and now, so don't unsubscribe. Today, I'd like to thank everyone that made this show possible. You gave us awesome interviews, tons of information, and you gave me a lot of fun making this. I want to thank all my guests, everyone who came on and talked to us about Fedora. I'd like to thank my co-host, Edward, our artist, Ryan Gorley, and our musician, Tricknology. I want to thank Audacity. I want to thank the OpenSUSE people for the Jitsi server we use. I want to thank Paul Frields for Pulsecaster where we record. I want to thank Ben Cotton for his Friday Fedora facts that gave me the news to cover on this show. I'd like to thank Michael and everyone at DLN for being our podcast network. And finally, I'd like to thank Fedora and every single person who helps make Fedora possible, whatever you do in the project. Finally, I'd like to thank everyone who personally helped me along my journey to get here. Thank you. I'm Grayson, and that was the Fedora Podcast, Season 2, Episode 10. Please subscribe, and we'll see you at some point in the future.